Hello and good afternoon, CSI257 Section 847 students. For the spring 2015 semester, the first 8-week term, for the Cisco Networking Academy course, Scaling Networks, which is also known as Networking 3. Today's PacketTracer tutorial is going to be on PacketTracer Activity 3.3.1.2, which is our Skills Integration Challenge for Chapter 3. And again, these are some of the most enjoyable PacketTracer activities to do because it really gives us an opportunity to take all of the skills that we've been learning to this point and to then implement those skills and to solve some complex problems at the CCNA level. So as you can see here, we have our addressing table at the top, which is typical for a Skills Integration Challenge activity. We also have a scenario we're basically going to configure the two routers to communicate with each other. We're going to be doing some sub-interface work, some VLAN work, some EtherChannel work, which was the highlight and the focus on in Chapter 3. And so let's go ahead and jump in. So inner VLAN routing, and if you remember when we talked about inner VLAN routing, we talked about a couple of ways to do it. You could do it on the switch itself with a multi-layer switch. You could then connect a router in and do the router to an individual VLAN, or you could do what is commonly referred to as router on a stick. And so it looks like we may be doing that with some sub-interfaces. So on router 1 and router 2, let's enable and configure the sub-interfaces with the following requirement. We're going to configure the appropriate 802.1q encapsulation, and we're going to configure VLAN 99 as the native VLAN. We're going to configure the IP address for the sub-interface according to our addressing table. So let's jump on to router 1 to start things out. And we're going to go to our CLI here. So we're in user exec mode right now. You can also see we're running OSPF. So I'm going to go to privilege exec and then into global config mode. And the interface on the router, it appears to be gig 00. So let's go into interface gigabit 00, and we're going to do a sub-interface 1 first. So we're doing the configuration up here on router 1. So we're going to set up all of those three interfaces right there. So we're going to go into interface gig 01. Now remember, there is an order of operations consideration here. So if I were to say IP address 192.168.99.1 and our subnet mask is a simple /24, we're going to receive an error message here. It says configuring IP routing on a LAN subinterface is only allowed if that subinterface is already configured as part of an IEEE 802.10, 802.1q, or ISL VLAN. So what does that mean? Well, that means we need to come back with our encapsulation. We know we're going to be using .1q, and this is followed by the VLAN ID, and so that's going to be VLAN 99 or VLAN 1. Yeah, VLAN 99. Sorry, it's over there at the end. VLAN 99, and it also turns out that VLAN 99 is the native VLAN. So we're going to go ahead and set the encapsulation on the first subinterface. Now we can come back and we can put our IP address on there. So we've configured the subinterface with the encapsulation so that when the packets are showing up off of the switch 1 connection, and that's going to be a trunk link on switch 1 side, multiple VLANs can show up, which means we're going to be seeing multiple VLAN tags. We need to know which subinterface is going to handle which tags. All right, so now let's go into interface gig 00.10. And again, we're going to start out with the encap .1q, and this is for VLAN 10. Again, we don't need the native because VLAN 99 is the native VLAN. So we'll set our IP address. So we'll say IP address 192.168.10.1, and this is also a /24. And then finally, let's go into interface gig 00, or I should say sub-interface gig 00.20, and we'll set our encap .1q and 20. And then we're also going to set the IP address. So this is going to be 192.168.20.1. and it is also a /24. So now we've configured our sub interfaces. We've set the native VLAN at 99. Let's take a look at do show run, and let's see what those interfaces look like. So you can see we've got 10, 20, and if I roll back up, we went right by a little bit. There you go. So we've got 3 sub interfaces configured. Let's take a look at our serial interfaces. Those seem to be configured, and the internet facing interfaces there, and then we had some OSPF config. Now, you'll notice that the link is still red, that gig 00 is down. So for this, we want to go up into the interface, the parent interface, and we're going to say no shut. And that is going to turn that link light green on router 1. It's also going to allow us to have those interfaces come up, and they're fully configured. So on router 2, it looks like we have much the same task. And so let's bring router 2 up, and let's work through router 2's configuration. So we're going to go from user exec into privilege exec and then into global config, where I'm going to go ahead and say interface gig, same interfaces, so gig 00 or sub interfaces .1, and I'm going to say incap.1q. It's VLAN 99 here as well, and it's going to be the native VLAN. So let's set our address 192.168.99.2, excuse me, .2. And we're going to get interface gig, or sub interface, I keep saying interface, it's a sub interface, gig 00.10, and incap.1q, and this is going to be for VLAN 10 traffic, and then interface gig 00.20. We're going to, oops, I forgot my IP address actually on interface 10, so we're going to say IP address 192.168.10.1, and now we're going to jump into gig 020, and incap, I'm going to recall previous command here, .1q20, IP address 192.168.20.1. So now we've got that all set up. However, our link is red. We need to go to the parent interface, gig 00, just like we did on router 1, and say no shut. And so that's going to bring those sub interfaces and the parent interface up for us. Okay, configure the IP addresses, so we're looking good there. So now routing, so it says configure OSPF v2 using the following requirements, remembering that OSPF v2 is IPv4 only, so we're only doing IPv4 here. So on router 2, I'm going to say router OSP, and actually let me do a quick do show run to make sure, because I thought I saw some OSPF set up, advertise the network for each sub interface, and that is not done yet. And then disable OSPF updates for each sub interface. Okay, so we're going to say router OSPF 1, and you can see where the passive interface statement's already in there. We want to add in network, and I'm going to say 192.168.99.0 with a .0 with a wildcard mask of 0.0.0.255, and these are going to be in what should be area 0, and the other interfaces, the 209.165 is area 0, and the 192.168.1, and I apologize there. This is just telling me that another packet tracer has been converted. All right, so, and I'm going to go with area 0 here to see, and let's see if we get points for that or not. It looks like we got a point, so we should be good. Let's go ahead and set subnet 10 for area 0. Do we get a point for that? We do. Okay, so it's going to be area 0 and 20. So we've got 99, 10, and 20. So those networks have been added, and we want to do a passive interface on gig 00.1 gig 00.10 and gig 00.20. And again, those are the interfaces that are facing our LAN segment. So since we don't have any OSPF speakers in our southbound facing direction, right? Because I'm on router 2, so we passive interfaced all of our sub interfaces here because I don't want OSPF hellos making their way down to switch 2, because switch 2 is not doing OSPF, right? So there's no reason for me to have OSPF hellos propagating down to switch 2. So we passive interfaced all of our sub interfaces. All right, so we've got that taken care of on router 2. Let's step back to router 1 and let's do much the same thing here. So router, and I believe I saw some OSPF config here earlier. We did. So let's say router OSPF 1 area. Oh, I'm sorry. Just router OSPF 1 for now. And we're going to go ahead and add our network statements in. So network 192.168. And on router, yeah, it's the same thing, 99.10. All right, so we're going to say 99.0, 0.0.0.255 for our wildcard mask, representing a /24 area 0. And let's get 99, and we're going to get 10, and we're also going to get 20. And so this is activating the OSPF process on those for those network, advertising those networks, right? And so now what we're going to do is we're going to passive interface gigabit 00.1.10 and .20. All right, so that takes care of the routing we were asked to do. Let's now step down into the VLANs. So, and it looks like we've got quite a bit going on here with VLANs. So for all switches, create VLAN 10, 20, and 99. So I'm going to start here on switch 1. And let me see if I can roll this up a bit. We're going to cut off the internet here for right now. And we're going to stay with switch 1. All right, so on switch 1, we'll go from user exec to privilege exec, and then into global config, where I'm going to say VLAN 10, VLAN 20, and VLAN 99. So switch 1's got the VLANs configured. So configure the following static ports for switch 1 and switch 2. So FA01 to 09 should be access ports in VLAN 10. FA010 to 19 should be access ports in VLAN 20. And 20 to 24 in gig 01 to 12. And that may be a typo. We'll check on that. Should be in VLAN 90, native trunks for VLAN 99. So let's start out with our first range here. So we're going to say interface range FA 0/1, and it wants us to go all the way up to 9. So I'm going to say no shut. I'm going to say switch port mode access and switch port access VLAN 10. Then let's change our range. Let's go to the next range. Interface range FA 010 to 19. And we're going to say no shut. And we're going to say switch port mode access. And then switch port access. And these guys should be VLAN 20. And then finally, we're going to go to FA0, interface range FA020 to 24. And can I get gig 01 and 02? Yeah, it doesn't. Oh, I was going to say it might take it, it might not. Let's make sure here. So int. All right, it looks like we're able to snag that whole range. We'll see here. So we'll say no shut, and those are going to be as the native trunk for VLAN 99. So let me make sure that this is going to be what I think it is. So switch 1, yes, 23 and 24. So these are all going to be trunk ports. So let's say no shut on all these guys. Switch port mode trunk, right? So we'll turn them all into trunk links. And the native trunk for VLAN 99. So then switch port trunk native VLAN 99 on all of them, right? So that takes care of switch number 1. Let's step over to switch number 2, and we're going to do much of the same. So we're going to go to the CLI mode here, and we certainly have inconsistent. We should have inconsistent error messages here because we're tweaking the native VLAN, and we just did switch 1, but now we're on switch 2. So switch 2 is going to be configured the same. So we're going to go from user exec into privilege exec and then into global config, and let's go ahead and knock out the VLAN creation. So we're going to say VLAN 10, VLAN 20, and VLAN 99. And then let's go into our interface range. So FA01 to 09, and then we're going to say no shut, and then we're going to say switch port mode access, and switch port access VLAN 10. And then we're going to change to interface range FA010 to 19, and these guys are going to be, we'll say no shut to make sure they're all up, and then interface, and then switch port mode access, and then switch port access VLAN 20. And finally, we're going to get interface range FA020 to 24, comma, gig 01 to 2. And again, it appears that that is a typo right there. That it should say 01 2/02 or 2. Right, but there is no 1, 2. We can confirm that here in a second. So I'm going to say no shut, and I'm going to say switch port mode trunk, and then we're also going to say switch port trunk native VLAN 99, right? So you can see we've got some unblocking that's taking place between switch 1 and switch 2 because now their configurations are the same. Or I should say, probably better put to say they're compatible at this point. So let's do a do show IP interface brief because I want to make sure there is no gig 1.2, and there is not. That's just simply a small typo. All right, so let's go ahead and jump on to switches 3 and 4 and repeat what we just did on switches 1 and 2. So here I am at user exec. I'm going to go into privilege exec mode, into global config, and we're going to say right out of the gate, VLAN, let's make sure we've got this right. Yep, VLAN 10, VLAN 20, and VLAN, 99, sorry, and VLAN 99. Now, the ports here are going to be configured the same, so we're going to say interface range FA01 to, 01 to 9, no shut, switch port mode access, switch port access VLAN 10, interface range FA010 to 19, or I'm sorry, 10 to 20, and that's a change, right? There's a very subtle change right there. It's asking us to use FA020, and let me confirm on switch 3 and switch 4 that 20 is not being used, and it is not. All right, let's make sure up there on switch 3 and 4 that 20 is not being used. Okay, so we're good there. So interface range FA010 to 20, and we're going to say no shut, switch port mode access, switch port access. What VLAN do we get to access? VLAN 20. And then finally interface range FA 0/21 to 24 and gig 01 to gig 02. And so these guys, it's going to be no shut, switch port mode trunk, and then switch port trunk native VLAN, VLAN 99. And you can see the inconsistency now. It's now unblocked between switches 1 and 3 because we've been able to put on the proper native VLAN and the settings to make switch 3 and switch 1 now compatible. So last but not least, let's jump on to switch 4. And let's take a look at switch 4. So we're going to go from user exec into privilege exec and then into global config, and let's go ahead and knock the VLANs out. VLAN 10, VLAN 20, and VLAN 99. And switch 4 is going to be configured the same as switch 3 with respect to the interface range. So interface range FA01 to 9. We're going to say no shut, switch port mode access, and then switch port access VLAN 10. Interface range will now change to FA010 to FA020, and we're going to say no shut, and switch port mode access, and switch port access, which VLAN are we accessing? VLAN 20. And last but not least, interface range FA021 to 24, and then gig 01 to gig 02. So we're going to say no shut, switch port mode trunk, switch port trunk. What is our native VLAN on the trunk? VLAN 99. All right, and so now those are also going to move to the consistent state, right? They're being unblocked. And so that takes care of our VLAN and access and trunk port configuration. So let's take a look. Where are we at right now? We're going to be jumping into the ether channels. And as you can see here, this is going to start to get a little hairy with respect to keeping things straight. Which ports between which switches, which port channel group. So let's go ahead and jump in on switch 1. And we're going to say interface range, gig 01 to 02. And this is between switch 1 and switch 3. So I'm going to say channel protocol. I always like to set the channel protocol to make sure we're good. And then we're going to say, and it's all LACP, right? So all LACP. So channel, group, and this is port channel 1, mode, and we're going to make everything active. So channel group 1, mode active. Now let me step to the other side. We'll go over here to switch 3. So I'm going to jump back and forth to make sure that we're doing each end in order. So I don't want to just roll down the left-hand column for device ports and then switch over and do the other one. We're going to go one by one to make sure everything comes up the way it's supposed to. So interface range gig 01 to 02. And now what we're going to want to do is we're going to do the channel protocol, channel protocol LACP, and then channel group is going to be 1 mode active. And so now let's go ahead and do a do show ether channel. You can see it shows channel group 1. Let's do a do show ether channel summary, and there we go. Our first port channel is now up. We're running LACP, and both ports are in the bundle. So let's go to port channel number 2, which will be between switch 2 and switch 4. So I'm going to say interface range GI01 to 02. We're going to say channel protocol is going to be LACP. Channel group is going to be 2 mode active. And now let's step over to switch 4, who is going to be the partner. And we're going to say interface range GI01 to 2. And channel protocol LACP. Channel group is going to be 2 mode active, and then it should come up. So do show ether channel summary here. And there we go. And so port channel 2 is now up between switch 2 and switch 4. The links show red, but what's happening is every time we're making these changes, spanning tree is having to do a lot of, the word is escaping me right now, convergence. It's having to converge quite a bit. A lot going on in our topology here. All right, so that was number 2. Let's jump down to number 3. So back over to switch 1. And we're going to say interface range FA023 to 24. And this is going to be channel protocol LACP. And channel group, it's going to be channel group 3 mode active. And so who is my partner on the other side? It's going to be switch 2. So back to switch 2. Change our interface range to FA023 and 24. And FA023 to 24, and then we're going to say channel protocol, LACP, and then we're going to say channel group is going to be group number 3 mode active. All right, so let's do a do show ether channel summary on 2, and there we go. We've got 2 port channels set up, and let's check on switch 1. So do show ether channel summary, and the same thing, and all of our ports are up and everything looks good so far. Let's move on to number 4, port channel 4 on switch 3. So we're going to say interface range FA023 to 24, and we're going to say channel protocol LACP, and then channel group is going to be 4 mode active. And so who's my partner on the other side? It is switch 4. So now let's configure switch 4. Change our interface range to FA023 to 24. Channel protocol is going to be LACP, and then channel group is going to be 4 mode active. So now if I do a do show ether channel summary here on 4, there we go. We've got our 2 port channels both configured and ready to go. These messages here are because we still have got a little configuration work to do. So now down to ether channel 5, right? So it's between switch 1 and switch 4. So I'll come over here to switch 1, and we're going to say change our interface range. So interface range FA021 to 22, and we're going to say channel protocol LACP, and then we're going to say channel group is going to be 5 mode active. And so 5 on switch 1, his partner is going to be switch 4. So here we come over to switch 4, and we're going to change our interface range to FA021 to 22, and I'm going to say channel protocol is LACP, and then my channel group is 5, and the mode will be active. And there we go. So do show ether channel summary, and now we've got 3 of the port channels configured here on switch 4. Let's get down to our last one, which is going to be port channel 6 between switch 2 and switch 3. So let me come over to switch 2, and we're going to change our interface range. So interface range FA021 to 22. So channel protocol LACP, channel group is going to be 6 mode active, and that was switch 2, and on the other side it's switch 3. So let's jump over here to switch 3, and we're going to say interface range FA021 to 22, and channel protocol LACP, channel group is going to be 6 mode active. All right, so do show ether channel summary. We now have 1, 4, and 6 on switch 3, and we're still receiving some native VLAN mismatch errors between switch 4 and it's on port channel 4. So let's continue to work here and let's see if maybe we overlook something. All right, so for spanning tree, configure per VLAN rapid spanning tree, which is the IEEE spanning tree mode, PVST, so IEEE spanning tree protocol, the legacy standard which Cisco took, and with 802.1q trunks it's referred to as PVST plus. So if I were to do a do show interface trunk right now, I'm pretty sure we're 802.1q across the board, so this would be referred to, the mode would be PVST plus, not PVST. If it was PVST, it would only have, ISL as the trunking protocol. So remember, and we're, oops, I didn't want that. I want to clear that, and just wanted to come over here. So remember that per VLAN spanning tree, and that is not what we wanted to do. I want to exit out of that, and let's do Control Z. So PVST would mean that we are using ISL as our trunking protocol, right? PVST plus means we're using 802.1q as our trunking protocol, right? And remember that the original spanning tree, the 802.1d, right, referred to commonly as just STP, that Cisco took the standard, right, threw their own little secret sauce in so it would work with the ISL trunks. And then when 802.1q came along, they just simply said, okay, it's PVST plus, right? So remember that, because this is always a point of confusion with spanning tree. Okay, so let's come back over here, and we're going to configure switch 1. Let's go ahead and knock out switch 1 first. So if I do a do show span, what mode do we have right now? You can see it's IEEE, and that's the mode that we want. So configure per VLAN rapid spanning tree mode on all switches. So I'm going to go ahead and say spanning tree mode PVST, right? And is it, oh, I'm sorry, per VLAN rapid spanning tree. Okay, I misread that. So we want rapid per VLAN spanning tree. So that's okay. That just changes the conversation over here to mean that rapid per VLAN spanning tree was based off of ISL trunks as well when you're doing ISL trunking, right? And rapid per VLAN spanning tree plus, same thing, 802.1q trunks, right? Now, these guys are based off of the 802.1 lowercase w IEEE standard, which was referred to as Rapid Spanning Tree Protocol, right? Whereas this was just the standard spanning tree protocol, which we see as IEEE on the switch. All right. So let's go ahead and configure, and did we already do that? Yeah, rapid spanning tree. So we're going to set that up. And then on switch 1, we want to set the spanning tree for VLAN 10. We're going to set the priority to 4096. So here the macro is not going to work for us. So this is where I'm going to say priority 4096, right? And for VLAN 20, I'm going to set it to be, for VLAN 20, the priority to be 8192. So it will be the secondary, right? The backup root bridge. So do show run. You can see right there we've got spanning tree mode rapid PVST. We've got spanning tree VLAN 10 priority 4096 and spanning tree VLAN 20 priority 8192. So let's jump over to switch 2. And we're going to go ahead and set the spanning tree mode to rapid PVST. And we're going to say spanning tree for VLAN 10. The priority is going to be 8192. So this will be the backup root bridge for VLAN 10. And then we're going to set the spanning tree VLAN 20 priority to be 4096 to have this bridge serve as the root bridge for VLAN 20 traffic. So let's do a do show run real quick. And there we have it. So switch 2 is going to be the primary root bridge for VLAN 20 traffic. It will be the backup root bridge for VLAN 10 traffic. All right. So now let's go on. We got to set the spanning tree mode properly. Oops, sorry about that. Properly here on switches 3 and 4. So I'm going to say spanning tree mode rapid per VLAN spanning tree on switch 3 and spanning tree, whoops, I guess we'll back out of this here. Spanning tree mode rapid PVST on switch 4. And so that takes care of the rapid per VLAN spanning tree, and the priorities are the default. So let's do a do show run. Let's make sure that the mode's rapid PVST. If I do a do show span for do show spanning tree, so 32768, and that is our bridge priority, so that's good. We're good there. And it looks like we're missing 2 points, and I'm wondering switch 1 and switch 3. So we're still receiving these native VLAN mismatch errors. So before I go take a look at the activity, it's on port channel 5 on switch 1. Or VLAN, the VLAN is 1, sorry, with switch 1 Ethernet 02199. So the native VLAN was overlooked by me between switch 4 and switch 1 is what the errors are indicating, and it looks like the problem is over, or it looks like the problem is here. So let's say do show run, and let's take a look at that EtherChannel link. It's possible that we did not. So native VLAN 99, and this is going to be FA 21 and 22, and it shows the gig ports are also not too happy. There's trunk native VLAN 99, native VLAN 99. So let me go over to switch 1 and let's take a look at switch 1. And he's reporting the same errors. Did we not do this? Let's make sure. And double check here. We've got so 20, and this goes back to when we did the range command. We didn't pick, or we did pick 20 as for 1 and 4. So let's take a look at this. So switch 1 never used FA020. It used 21 and 22, and it used 23 and 24. However, we pulled that port in, and if you look here, what I'm referring to is, remember, it caught our attention that this wanted FA, or did not want FA, oops, sorry, FA, let me back that out there. FA020 is not there. And here it is. So the errors that we're seeing over here with this native VLAN mismatch on 20 and 21, or on 20 for at least some of them. So switch 1 never used port 20, but yet it got set up. So let's do this. We're going to go ahead and we're going to pull port FA020 out of VLAN 99, and we're not going to make it a trunk port, and I'm going to put it back in as an access port, because I think that this was supposed to be identical. So 20 should be in VLAN 20, not part of this native trunking setup that we've configured here. And let me double check this to make sure. So switch 1 used 20 and 23 and 24, 21 and 22. It never used 20. So that might be our problem. So let's check this out on switch 1. So here's what we're going to say. Interface FA020. I'm going to say no switch port mode trunk. I'm going to say switch port mode access, and switch port access VLAN, and it would have been 20. So now let's do a do show run, and we want to check out FA020. So there it is, and we want to get the no switch port trunk native, even though this is being overridden right now by the fact that we've set it to an access port. I want to remove that. Oh, sorry, native VLAN. And where are we at here? Whoops, there we go. Native VLAN 99. We want to pull that statement off of that trunk, or off of that port. So we also have a native VLAN mismatch discovered on port channel 5, and this is on switch 1, and port channel 5 is going to be going between 1 and 4. So let's see what 22 and, make sure I'm reading this right. So let's make sure that 21 and 22 are properly set. So 21 native VLAN 99, 22 native VLAN 99, 23 native VLAN 99, 24 is correct, and 01 and 02 are correct. So let's come over here to 4. And 4 is also seeing the same do show run. So let's check out our ports here. So 21 is native VLAN 99, 22 is native VLAN 99, 23 is native VLAN 99, 24 and gig 01 and 02 are properly set. So let me check switch 2, which is also getting native VLAN mismatch errors on port channel 3 with switch 1. So let's check his ports out. So switch 2 also has that misconfigured FA020 interface. So we're going to go to interface FA0/20, and we're going to say no switch port mode trunk, and we're going to say no switch port trunk native VLAN 99. We're going to make this an access port. Mode access, switch port access, VLAN 20. And let's see, that should be it. Yeah, so that's interesting that they had 19 and 20, or 20 out of there. So do show run. So 21, 22, 23, and 24 have native VLAN 99. We still have native VLAN 99. And you can see it's interesting that we're actually losing points when we pulled port 20 out for whatever reason. And let me make sure I'm reading this right. So on switches 1 and 2, 20 should be a trunk with a native VLAN of 99. Let's look at 04 real quick before I go back and change that. And let's see. So 21, 22, 23. So the native VLAN is correct on those switches. Let's check switch 3 and do show run. And the native VLAN is correct on all of these ports as well. So let's go ahead, let's go back, and we will say on interface FA020, we're going to add that back in. We're going to say no switch port mode access, no switch port access VLAN 20, and we are going to say switch port mode trunk and switch port trunk native VLAN 99. Make sure it's not shut down there. And let's do the same thing back over here on switch 2, and then we'll go take a look. And maybe, oh, well, actually the trunk port up to the router. Let me take a look at that. So let's do interface range. That may be where, you know what? I think I know where the problem is. So here, because it's showing between the switches, but let me check. I may know where it's at. So FA020, no switch port access, VLAN 20, no switch port mode access. And so this is going to be switch port mode trunk, switch port trunk native VLAN 99, right? So we're at 98 points right now. So on switch 1 and switch 2, this link right here that goes up to router 1, does it tell us? It doesn't tell us what link that is. Oh, that's link 20. Okay. All right. So that makes sense now. So that is link 20. Okay. And did it say that up there and I just completely missed it? It did not. So the link between switch 2 and router 2 is FA020, which is why it needs to be a trunk port. And the link between switch 1 and router 1 is FA020. So again, this is correct, and that's how those ports should be configured. And again, in the troubleshooting here, just trying to narrow it down. So let's take a look at our check results and let's see where it is that it thinks we're off. And so it's showing on router 2, the IP address for subinterface 10 and 20 is incorrect. So let's go take a look at that. Excuse me. Let's go take a look at that. And router 2, go from user exec into privilege exec. We'll do a show run. And there's gig 00. And sure enough, we fell into the trap of putting the default gateway down from router 1. So let's go to global config, and I'm going to say interface gig 00.10 IP address is 192.168.10.2, not 1. And so now that's been resolved. And let's go into interface gig 00.20. and set that interface up. And so now that has been done correctly. Now we're still seeing these native VLAN mismatch errors, which I believe are in error. So here's what I'm going to do. I'm going to type in, we're going to save the config on router 1, and I'm going to say reload. I'm going to come over to, I'm sorry, on switch 1. We're going to come over to switch 2, and I'm going to say end. I'm going to save my configuration, and I'm going to reload. And then we're going to go to switch 3. I'm going to say end. I'm going to write my configuration, and I'm going to reload. And then finally on switch 4, we're going to do the same thing. Write mem and reload. All right, so the reason I'm reloading all of the switches is because I want to make sure that PacketTracer, obviously we walked through and saw that the native VLAN was actually 99 on all ports. So I want to make sure that PacketTracer isn't hung up in some form or fashion with the thinking that the native VLAN is mismatched when it is not. But let's see what happens when it comes back up. And now that I'm looking at these errors, I'm wondering, and let's see if everything settles down here. So let's go ahead and do, and we're waiting for any native VLAN mismatch errors to come up right now. So we're still 100%, so we got a flurry of errors there. Whoops. Let me do a show run here. And you know what I'm wondering is if, yep, and we're still seeing those errors. And I think I see the problem is that I did not set for the port channels, the port channel interface, the native VLANs. So do show EtherChannel summary. Whoops. And that looks like it might be at int PO1. So switch port trunk native VLAN 99. We're going to go into int PO3, switch port trunk native VLAN 99, and then we're going to go into interface PO5, and we're going to say the same thing, switch port trunk native VLAN 99. And now let's walk over. So again, fell into the trap of doing the configuration under the specific interface. So again, I like to refer to this as a fortuitous failure, right? So caught up doing the configuration on the physical interfaces and not doing it on the port channel interface. And you can see the result is that even though I set it on the physical interface, the logical interface, which is the port channel interface, that's where it needs to be set. So EtherChannel summary. So we're going to go into global config interface PO2, switch port trunk native VLAN 99, interface PO3, and this is what should have been done initially. I went right by it. Switch port trunk native VLAN 99. Whoops. And you may have been out there watching, screaming at the monitor saying, just go into the actual logical interfaces. And then port channel 6, interface PO6, and switch port, trunk native VLAN 99. So that takes care of switch 2. Let's hit up switch 3 and show EtherChannel summary. And we're dealing with 3 port channels, 1, 4, and 6. So global config, int PO1, switch port trunk native VLAN 99, and then 4 int PO4, switch port trunk native VLAN 99, and then 6 PO6, switch port trunk native VLAN 99. All right, and last but not least, switch 4. We're getting quite a workout here with the setting the native VLAN. So we'll go from user exec to privilege exec into global config, do show EtherChannel summary. Whoops, EtherChannel summary. And 2, 4, and 5. So int PO2, switch port trunk native VLAN 99, and switch port, oops, sorry, we're going to drop back to int PO4, switch port trunk native VLAN 99, and then interface PO5. Our final interface is going to be switch port trunk native VLAN 99. And so now all of those native VLAN mismatch errors should not reoccur. And this was before we got over to switch 4. Same thing. All right, so we'll give it a couple seconds here, but we should now be 100% complete. It actually gave us the points for completion, apparently not checking to see if it had been set under the port channel interface. And as you can see, we are no longer receiving those native VLAN mismatch errors. And so I apologize for that. Set it under the interfaces and completely look past the fact that it needs to be set on the logical port channel interface. And we actually, ironically, I talked about this in the PacketTracer 3.2.2.3 activity, which preceded this one. Okay, so this has been PacketTracer 3.3.1.2, the Skills Integration Challenge for Chapter 3. And hopefully this has cleared up any confusion you might have had. And thanks for watching. I will see you guys on Saturday.